how many people here, their company or themselves are building a physical product, just kind of by show of hands? So a few, okay. How many folks have actually had to import things into the US before? Okay, so a few. So what I hope is that this is a good introduction to this kind of entire space of how do you build physical products amidst a trade war. So I'm going to talk a little bit today about, one, how do you build a product? That's really my passion. But two, also, what does this trade war mean and how do we think about it and how do we build systems? I'm a co-founder of Fictiv, which is a virtual contract manufacturer. We're based in San Francisco. We have about 100 folks, a team of about 80 that's in San Francisco, a team of 20 in China. We've raised almost 60 million to date, and we've shipped hundreds of products from companies. So when we talk about product development, this is my everyday. This is, I live and breathe hardware and manufacturing. And so I'm really excited to talk to you a little bit about this today and what this looks like. So let's dive in. Maybe second to my love for manufacturing is probably my love for data. And so I want to start this conversation off with some facts, essentially. So this is the 2019 State of Hardware. This is our 4th year putting this on at Fictiv, and we surveyed over 1,000 people. That's a part of our community. It represents almost 70 different industries across the globe. So this is boots on the ground manufacturing and hardware development. And we asked them a simple question in this survey, among others, and the question was, how did the tariffs in 2018 affect your product development? And some of these numbers are pretty astounding to me. So basically 64%, so this number right here, said that they had an increase in their material costs. So we call these COGS, or the cost of goods sold in the BOM. 19 or almost 20%, so 1 in 5, had project delays as a result of this. And probably shockingly, 5% actually canceled their projects. So if you think about these numbers just grounding as we talk about today, this is what's happening on the ground. There's a trade war going on. I don't think there's any argument about this whatsoever. But what we're seeing is that it's really affecting companies across the board. Not just large companies like the Apples of the world and Teslas and whoever, but small companies as well and kind of everything in between. So I want to talk a little bit about why this happens to help inform, but mostly what can you do? So for the folks that raise their hands, what can you actually do in your business today to help drive towards change here? And so I'm going to start with a framework that we have, which is around 2 different speeds, which is primarily what I'll talk about for why we have this tension that exists between manufacturing and tariffs or global trade. And the one is slow. Supply chains move slow, like glaciers. As a manufacturer, when I'm from Ford prior to starting Fictiv, we move incredibly slow. And we move slow because we're methodical, we're planners, we're incredibly good at building Gantt charts. If no one knows what a Gantt chart is, it's the most exciting Excel template you've ever seen, but we move glacially slow. But it's on purpose because building things is really hard. When you combat that with policy changes, we were just talking about scooters in cities and these things, they move relatively fast. We're talking about quarters and months. So what happens here is that policies can change on a quarterly basis, depending on who's in government in 2 different countries, what's in city, what's the political flavor at the time. And what happens is it creates a lot of tension between these 2 different time speeds. And so one of the key things that's missing, which we'll talk about today, is the agility that's needed in hardware development. Hardware companies aren't agile. Manufacturing isn't known to be agile. And what we need to actually introduce is some way to be more agile. And we'll talk about that a little bit today. But before we get into the thesis, I want to talk about my background. So I'm a mechanical engineer. I studied what's called mechatronics, mechanical electrical systems at Stanford. I did a couple startups out of school, but I primarily cut my teeth at Ford, building infotainment systems, so dashboards of vehicles. And there was this premise when I came, and they said, hey, there's this whole BYOD movement, and we need to insert iPad here. Literally, Paul Mascarenhas is the CTO at the time, and he said, Dave, you're the first hire at Ford Silicon Valley Lab. We need to put an iPad here. And we went through this whole study, and the thesis that came out of this was pretty interesting. It was one where a vehicle, I'm not sure if folks know this, takes 4 to 6 years to develop. So here in 2019, I'm developing cars for 2025. An iPhone is 6 to 8 months. That means you're gonna have 12 iterations of iPhones in the time it takes me to launch one vehicle. So if I was to build a car in 2019, I have to guess what the iPhone's gonna look like in 2025. Or better, if I'm in 2012 when I was doing some of this work and I had to develop something for today in 2019, you think I could have known we would have foldable phones today? We didn't even have lightning ports at that point. So we're trying to design all these things to put an iPad here, but there's all this technology that hasn't been developed. There's speed of innovation which changes. So I do what probably any good engineer does, and I break down the problem into digestible small chunks, and it starts with supply chain. It took me, basically the reason why it's 6 years is it takes me months to get prototypes back, because I'm using Ford supply base. So I said, okay, we have our tier 1, tier 2, tier 3 suppliers. What can we do differently here? So I said, great, we're in Silicon Valley, we're gonna do it differently, we're gonna use local supply. We're gonna just develop local base so we can do this faster. So we moved from kind of this month time period to get prototypes back to weeks. Okay, that's pretty good. Now I go from every 12 weeks to get a prototype to put the iPad there to every 2 to 3 weeks. Still too slow, right? My friends over in software on the mechatronics side are whipping out like hourly code reviews and pushing it out. So what do we start to do? We're Ford. Well, we just buy machines. We build a whole lab. So we spend $2 million. We buy a mechatronics lab and we set it up. And what happens to mechanical engineers when you build a lab and you put in a bunch of shiny toys? The engineers play with the toys. We stop putting iPads here and we start running amazing 3D printers and laser cutters and machines. Like lasers and engineers is like the best thing in the world. But we stopped innovating was the big thing. And so we had this premise where we were supposed to build BYOD and we were supposed to have this modular infotainment system. And as a result, what we were left with was this problem where we spent all of our time finding, vetting, and managing vendors. And we figured that we had these crazy ambitions for what we wanted to build, but our ambitions didn't match the tools we were actually using. So you might be thinking, okay, this is Ford though. They're 100 years old. Like, they're not Tesla, right? They're not the most innovative company, but this is happening across the board. And I want to show you it's not just Ford that has to deal with this. Anyone remember this headline in the news maybe about 6 months ago? Kind of, yeah. Harley Davidson got caught in the crosshairs of a trade war because they wanted to build bikes overseas, motorcycles overseas, specifically in Southeast Asia and in India. But the reason why wasn't just because of tariffs. It's because they said, hey, in 2027, we think more people will be riding motorcycles in India. And they shouldn't be riding any motorcycle, they should be riding Harleys. So they're sitting here in 2018, projecting 9 years in advance what my supply chain needs to look like. And meanwhile, they get this crossfire that happens due to politics that are going on. $40 million, that's what they were talking about due to the tariffs. So they had an economic decision to make and a demand gen decision to make as well. And this set off a lot of debate, I would say, as a country. Another favorite one, this is Apple. How many people, by show of hands, have a smartwatch on their wrist right now? Okay, cool. All of you play with me. I want you to just reach out and touch your smartwatch and now move to that little button on the side. That button has 12 different components in it, 5 different manufacturing processes, maybe 6, 7 different materials. You want to know what freaks mechanical engineers out? That button, the button that you just touched. Like I'm a little bit, I got sweat right now. Because you want me to build that on your wrist, and if a single component fails, or I can't get the supply chain, or it can't get imported, the entire watch doesn't work, all because that little screw that like assembles in there, a single component. We're talking about cars. We're talking about motorcycles. I haven't got to rockets yet, and I love space, so we could get there next. But we're talking about the things that makes me sweat, and it's a button on your wrist. So when we talk about product development, when we talk about how challenging this is, I want you to think about the complexity that's sitting on your wrist, just to bring it home to you today. And Apple's not actually out of the trees, if you will, even with the Harleys and the Ford. Anyone remember this headline? that time Apple's manufacturing plant got screwed? This was in Texas. This is where they assemble the MacBook Pros. And because of a single screw, the entire assembly line stopped. A screw, not a circuit board, not a component that's the chip that runs the whole thing, not even the screen or some critical component, a screw. And this is, besides Amazon, the wealthiest company in the world. So what happens if I don't have the resources of Apple? How do I combat an actual global trade that's going on and a war that's happening? How do I build supply chains that are truly agile if it even affects Apple? How do I do that? It's pretty challenging. Everyone's a little gloom right now. They're like, oh, I have no idea. Okay, well, we're gonna get to some solutions, but stay with me. I want to talk about some macro trends that actually starts to enable this. So this is an economic study done by McKinsey. Everyone should know McKinsey here. And this is looking at the investment in IT. So think technology in two different sectors. The blue line here is manufacturing, and the green line is technology or telecom space. This is looking at the amount of dollars that's been invested. So what you can see is the blue is flat. The amount of dollars that we've invested into technology and manufacturing hasn't changed over 30 years. If you compare that to the amount of dollars that have been invested into the telecom space, your phones, or to technology, you can see that it's grown from 20 billion to almost 120 billion. McKinsey said that we've lost 2 decades of productivity as a result of the lack of investment. I know we have at least one VC in this room. I'm not going to look at him, but you should invest some more dollars into technology for manufacturing. When you couple this right here with the fact that productivity, so how many dollars per employee a manufacturing employee can bring in, that's been declining since 2000. 20 years our productivity has been going down, and yet we don't invest in technology in the entire ecosystem. Cool, we got the macro trend, right? This is McKinsey, large global consulting company, telling us what the macro trends are. I want to zoom in a little bit because I'm a mechanical engineer. This is what the world looks like for us. Our friends over in software get to use amazing new technologies that come out every day. AWS, Jira, GitHub, it's these tools that constantly change. You want to know what we use to build rockets? PowerPoint and MS Paint. And MS Paint is a little bit up from KidPix if you're there. You want to see 2 engineers start joking that are mechanical engineers? We decide who can draw better arrows on a drawing to communicate with a Chinese supplier. And I know everyone's looking at me like, ha ha ha, funny Dave, this can't actually be the way that we build rockets. This can't be the way that Ford builds cars. It can't be the way that Tesla actually builds that dashboard with a beautiful 17-inch screen. I promise you it is. It looks like this. This is a real example. This is from a billion-dollar company, and you can't even read what's on there. That's kind of on purpose, but this is a part, and they're trying to communicate to us what the design intent of this thing is. You can see this little arrow that's definitely done in Microsoft Paint that says you have to tap a hole to an M1.6. A tap is where you put a screw into. And then you see this blue arrow that nobody can read. I can't even read it on my Retina display. But I'll tell you what it says. This call out right here says surface is important. I'm a manufacturer. I'm in China. I don't even speak English. And surface is important? What am I supposed to do with that? How do I communicate this design intent? So software engineers get this whole, like GitHub, and you can have change control, and you can have versioning and branches and commenting, and we get surface is important. When you don't invest in technology, you use tools that are off the shelf. And so as we start to talk about supply chain today, and we talk about a global trade war, I want you to think about this idea of surface is important, building that little button that's sitting on all of your wrists today. This is the end result. We talked about these 2 speeds, and basically what happens is you get the cheetah coming down on the Harleys and Apples. When you don't invest in technology, you have these 2 different speeds, you have a lack of agility, and as a result, what happens is that you get a lot of tension. So now I'm going to do a little something mean here. I'm going to sprinkle a little bit of fire and fuel to the fire that's already roaring. I'm going to put this in. A single policy decision can completely disrupt, even a tweet, how and what the landscape looks like for our manufacturing companies. This is a real tweet. This is liked 121 times. This is crazy to me that we can change things so quickly with a single tweet. But what most people don't realize is that this trade war that's existing, it's actually just the flavor of the month. It's just a moment in time. So I want you to come on a little journey with me. We're going to go back in history. We're all going to get in our time machines, and we're going to go back to the 1930s. And this is Hoover talking about the farm crisis at the turn of the century. This is Hoover saying, I got this big problem in my hands, and what does he do? He puts tariffs on agricultural goods. Okay, so there wasn't 53,000 retweets of this, but there was 1,000 economists that actually called into the government to say you have to stop this. There's real economic changes that happened as a result of this. Let's fast forward. We're now in the 80s, and this is President Reagan. Same thing's happening, but this time the tariffs are on Japanese automobiles. And it was estimated at the time that it was $53 billion worth of economic impact as a result of this tariff. Let's keep going. We're now between Europe and the US, but this time we're not talking about automobiles. Between the Europe and the US, it was French handbags, British linens, and Danish hams, of all things. 3 years went by that the World Trade Organization filed litigations because of this trade. Doesn't stop, right? This cadence keeps going. This is George Bush now. It's on automotive. It's on oranges coming in. And if history tells us anything, we actually should prepare for this more. History will repeat itself. And I would actually argue that the frequency of the conflict between global trade will only increase. So what should we do? How should we actually plan a system that is more agile to respond to this? Rather than saying we need to get a fix to what the current administration is trying to say with global trades, how do we build an ecosystem, a manufacturing ecosystem that is able to change here? And that's what I want to challenge everyone in this room. Folks raised their hands, they said, I'm building physical products, I have to import goods, but how do we build something that's more agile? So I'm a little biased, but I'll say technology can be our friend. It can be our guide here. Obviously, I run a technology company in San Francisco, but I believe what we're missing in the discussion today is how can we leverage technology to make changes in days and weeks. Remember, I'm Harley Davidson, I'm planning in 2027. I'm Donald Trump in the current administration, and I'm making plans on a quarterly basis. If I can develop technology that allows me to be more agile, I actually believe we can build a better supply chain system. We can build something that's built on agility. And so what I want to talk about is a framework which was introduced by Michael Mendel. He's a doctor with his PhD that focused on the economic impacts on manufacturing. He's a part of the Progressive Policy Institute, and he built this framework that talks about 3 different ways we can invest in technology. Remember back to that McKinsey slide, where should we put our dollars? And it comes down to threefold. The first is digital machines. The second is digital distribution. And the third is digital networks. So I want to use this framework from Dr. Mendel to help talk about how you, each individual in this room, can better their supply chains if you're building a physical product. How you can actually help invest, start a company, or do something to help start driving some change here. Cool? With me? Right on. Let's keep going. All right, so let's talk about the first one, digital machines. Industry 4.0. Everyone should know Industry 4.0. This is the promise kind of by the German government that we're going to have connected factories. This is IIoT. We're going to have data that's in the cloud. Robots are going to be in the machine, in every factory, and it's going to be this beautiful world. I don't know about you, but in the last 5 years, every factory I've walked into, I don't see many robots. They don't even have Wi-Fi. Like my phone literally doesn't work when I go to China. And I would argue we're actually still in Industry 2.0. That there's this promise and premise of connected devices and cloud and IIoT and robotics and machine learning and AI and manufacturing. But let's get back to the fundamentals. What can I change today? What can I change to build this watch that's on my wrist? And I want to talk about things that are maybe a little bit more practical here. First one's Tulip. Anyone heard of this company? Awesome. I like introducing new things. Tulip's an awesome startup that's based out of Boston. Really smart founding team. They're a Series B company, all out of MIT's Media Lab. And what Tulip's working on is basically connected factories. But what they do is they take a software approach. It's like APIs. It allows you to take existing equipment and you just put sensors on them. And you have a tablet that just works right away. So imagine this. I want to build that watch that's on your wrist, and I can take a torque driver, that's just like a fancy screwdriver, and that measures how much torque I actually put, and it puts it into the database. It allows you to measure how many screws that you use, but the setup takes minutes, maybe an hour. This is a great product which you can use today, available today, to help build a better connected factory, to help build better connected machines. And if you're building a physical product, you should really check them out. Here's the second one, carbon and desktop metal. Anyone heard these? Probably a little bit more in the news, right? That these are brand new additive manufacturing technologies. What carbon is doing is they're speeding up the ability to go from digital CAD or designs to a physical product. They grow it in a matter of minutes. So most of the manufacturing that we do today is old technology, injection molding machines, CNC machines, with a little bit of technology on top. These are new ways to actually leverage technology to build products differently. Desktop Metal is doing a great job here. There's a lot of companies that are building composites and advanced material options that I'd love to talk with you about afterwards if you have questions on some of these digital machines. But what I'm trying to get across is there's a lot of new ways to build products besides just traditional methods. And the pairing of the two actually is where we'll see a lot of gains come. In manufacturing, we have to deal with this really annoying thing called physics. We live in a real world, and we have to move goods around everywhere. And one of the hardest things to do is distribution. Did folks remember reading in the news about Foxconn in Wisconsin and the factories they're trying to build a little bit? So they were going to build this brand new facility, invest billions of dollars to build a new factory to make flat screen TVs. One of the largest problems, besides the politics of this that I'll put aside, was infrastructure. You're in the middle of the US and we don't have infrastructure. Rail, water, transportation, employees, electricity, all this infrastructure has to get built. The reason why southern China, specifically Shenzhen or in the Delta area, works so well is because of infrastructure. Distribution is really easy. Remember, we have to move products around seamlessly. And if you're going to move products, it's about dollars. It's how much does it cost to do that? And that's what drives a lot of these decisions. And so by investing in digital distribution, we can, one, make it more efficient, which means it's generally cheaper. So I want to talk about a couple examples, one known, maybe one not so known. Hopefully everyone knows this company. How many people got something delivered to your door in the last 2 weeks, or in 2 days? Yeah, just like everybody, right? I don't go anywhere to buy anything. But what Amazon did, what most people actually just forgot, just maybe 10, 15 years ago, it was cheaper to ship goods from China to New York than it was from Ohio to New York. 1,000 miles, Ohio to New York versus, 10,000 miles from China to New York. That's mind-boggling to me. And what Amazon has done is by investing in technology, they're actually able to drop the cost to ship goods in a hyper-local area. They invested in robotics, machine learning, AI, and DCs, so distribution centers, to be able to do this more efficiently. And as a result, they built a digital distribution system. What's really cool, though, is how many folks have heard of Jet? So Jet was acquired by Walmart, and Jet is doing 2.0 of this. And already today, and what they do is you add stuff to the cart, they're looking at availability at the closest distribution center to your shipping address. And they change the cost of that good based upon the availability of the inventory. Like, if you want me to nerd out, this is the stuff that I just think is so incredible, because you get to actually drive economies of scale that are geared more towards small scale versus large distribution. And that's what companies like Amazon and Jet are really doing. There's a bunch of companies here as well. Another really cool one is Flexport. Have folks heard of this? So Flexport is probably tackling the second oldest industry besides manufacturing, logistics. Maybe logistics is older, I don't know, I won't debate that. But what Flexport is doing is that they give you a digital view into where your goods are anywhere in the world. So they allow you to track from boat to car to train to wherever it's gonna get on your front doorstep. And they give you an entire interface here. They just received $500 million in funding from Vision Fund, which is SoftBank, to go disrupt this. These folks are here to stay. And what they've done is I haven't seen innovation like this in logistics since 1952. Anyone know what happened in 52? The shipping container was invented. The first physical API is what I would call. Prior to that physical API, you put baskets onto a boat, and people had to unload a basket at a time, and they just moved all different size things. And then what we did is we made this API just basically a standard shipping container, which that is what allowed it to be cheaper to go from China to New York, just because of that API. Literally just a box. There's an entire book about this called The 90% of Everything. Awesome book that's on distribution and logistics, highly recommended. And the history of the shipping industry is crazy. But how to build products amidst the trade war, we'll talk about that for today. I want to get to digital networks, which is probably nearest and dearest to my heart. And what the idea behind digital networks is we already have existing infrastructure today, factories. Right? We have factories all over the place. We have factories in California, and Texas, and Michigan, and New York. Why do we need to build more factories? And the idea here, the final piece of the puzzle, comes down to access. So it isn't that we don't have enough factories or infrastructure, it's really just around access. Remember that Ford story I talked about, that the easiest access I had was our supply chain, right? Tier 1, Tier 2. And I said, we have local supply chain here that we don't have access to yet today, but is much faster. So we built that local network. But really, if you think about this, it's all about how do we think about getting better connections between this existing infrastructure today. Do you think that Tesla, when they first started 15 years ago, had the same access to supply that they had today? Probably not, right? They were convincing anyone to make anything. And so what I want to talk about today is if you invest in digital networks, can you actually give better access to an entire ecosystem? So I want to tell you a little bit about Fictiv, about what we do, and then I'll show you some other examples as well. We run what's called a distributed network. So we're a virtual contract manufacturer, and we don't own a single machine. So I'm a contract manufacturer, but I don't own machines. So what we do is if you're an engineer at Apple, you're an engineer at Tesla, or you're an engineer at a startup building a physical product, we allow you to order parts from machines which are idle or have extra capacity. We allow you to gain access to all these different machines, but we don't have to own them. So when Carbon comes up and they have a brand new machine, you get access to that. I don't have to buy it, I don't have to train people, I don't have to have capital to purchase it, I just give you access right away. And those same prototypes that I was waiting for maybe 8 to 12 weeks at Ford, we do in 24 hours. 8 weeks, 24 hours. I'm not changing any of the processes. I'm not messing with physics. I'm literally just doing digital networks. I'm removing inefficiencies of waiting in a long queue to produce parts. And we do this, and we drive dollars to local economies. So I take a local manufacturing shop that's in Texas, and they have CNC machines and a 3D printer. And I say, hey, there's a client that's in San Jose that's building a smart watch, and they need some parts machined. Smartwatch does not know there's an available machine in Texas. We connect the two together. Maybe there's an available machine in San Francisco that's closer. We'd connect that first. And we write software and technology to build this entire distributed network. And we're just focused on this for mechanicals. So think plastics, metals, composites. That's what we focus on. This is happening in the entire ecosystem. This is Hampu. They're based out of China, and they do this for PCBs, for printed circuit boards and assembly, so electronics. And what they do is they find an entire ecosystem of what's called SMT lines, and they allow you to order parts from these SMT lines, which are idle. But they do it through a digital interface. And what happens here is you're actually able to do the quoting, the logistics, the order management, and you get to order complex mechanical parts as if it was on Amazon. I don't have to say surface is important. I don't have to say put a tap here. I get to leverage technology to actually order things today. Cool. So 3 different frameworks: digital machines, digital distribution, and digital networks. So to kind of bring this home, I want to give you a real example of a company that's doing all of this today so you can see what this is like in real life. And maybe this helps you think about ideas for what you can do. How many folks here have heard of Quip? How many people have a Quip? Okay, so like 4. How many people have a Sonicare? Okay, throw out your Sonicares and go get a Quip. I promise you. So Quip is an electric toothbrush. And what they do is that it's like a Dollar Shave Club model. So every 90 days, they send you a new toothbrush head, toothpaste, and a travel toothbrush, or travel toothpaste. And it just comes in the mail. It's a subscription service. Every single day it's delivered. And what they've done is that they've leveraged all 3 of these technologies to get to market faster, at a lower cost, and disrupt probably a pretty entrenched space with Oral-B and Sonicare. Like, I would not want to go up against Sonicare. That is a name brand. That's like saying I'm going to go up against Kleenex or something. Like, it's pretty hard. So how did they do this? The first is in digital machines. Quip is a customer of ours, so we know them intimately, so I can talk about them well. That Quip first started with a lot of additive technologies to prototype very quickly. They were able to get their prototyping cycles down to days to be able to iterate on the design and functionality of this part. It's complex. It has to be waterproof. It's oral because it goes in your mouth, so it has to be food safe. It's plastics, it's metals, it's electronics. It's a complex good. They were able to scale up from here to leveraging traditional injection molding all the way up to robotics, 24/7 lights out injection molding to get their costs down. So they were leveraging all this advanced technology, which arguably their competitors never actually did or are doing today, to get to market. The second thing that they did really well was on distribution. So remember, they're a subscription service. You get this toothbrush delivered in mail every single day, or every single quarter, so every 90 days. So as a result, they don't sit in a box retailer, at least not for the subscriptions. You don't go to CVS to basically buy a new toothbrush head. I don't have to go on Amazon to find this, which means they don't have inventory, which means they do direct delivery, which means their costs are lower. So they built a business model around a consumer good, a toothbrush of all things, and they built in digital distribution. They said we can win here by having a digital supply chain for how we send things rather than the traditional Oral-B. I make a whole bunch of toothbrushes, they sit in a warehouse, they go from a warehouse to a box retailer to the consumer. That's a lot of work to manage that whole supply chain. And so as you think about how you build your own supply chain, or what your business model looks like today to actually be able to deliver your good, think about how you can tweak this. How can you change the business model to be more direct to consumer? And it's something I'd challenge you on. And the third is around digital networks. Obviously, Quip is a customer of ours, and so they came to us when Target said, hey, I really want to get your product on our shelves. Quip's like, whoa, we have a digital distribution network. Like, what do you mean you want box retailers? We don't even have packaging on this. And they had 8 weeks to do it, 2 months to get things on shelf. They leveraged basically this digital network of supply chain on demand, right? Machines that are available to produce parts today, and they were able to tool this up in 4 weeks and deliver solutions to Target, to that box retailer. Rather than using traditional supply chain to have to go and find all the packaging manufacturers. Remember, this is stuff that's not their core product, it's just packaging. They were able to do this in half the time that it traditionally would take because they leveraged a digital network to get it done. So I'll kind of round this out because I want to leave some time for questions. But what I want you to take home is, how do you build a product amidst the trade war? How can technology, when you couple it with supply chains, build agility into the ecosystem? I believe that we need a radical shift in how we think about how products are developed and delivered to our customers. I think we need to rethink this entire ecosystem so that the world-changing products that we're developing and the ambitions we have to actually do that match the technology that we use to actually build this ecosystem. I want you to think a little bit and pay attention to where our investments go in this ecosystem. Thinking about how if you apply technology, where we haven't invested many dollars in manufacturing, how we can change an entire industry, which hasn't changed much in the last 30 years. And my belief is when we actually do that as a technology community, that's what's going to enable us to actually build more agile systems amidst the trade war. Got some contact information. You can reach out to me here. If you want to get that report for the state of hardware, you can just go to fictiv.com/getreport, and you can download that entire guide. It'll be available in the next couple weeks here. And I think it's still open for respondents until the end of this week as part of it. Thanks for taking the time and listening, and hopefully you learned something.